All right, guys, we're gonna work on this review. So here's how you're gonna do these. Evaluate without a calculator. So we know that this is talking about the fourth index of the third root of 16. So this can be rewritten as this, right? Now, either way, you're going to be doing the exact same thing. So whichever is more familiar to you. This, we know the fourth root of, I'm going to do the root first, especially if it's a perfect, whatever, a perfect root. So this is the perfect fourth root of 2. The fourth root of 16 is 2. So now we get 2 cubed. That's going to be 8. All right. So all I did was I can write it like that, or I can write it like this, right? The fourth root of 16 cubed. These are written, these are the exact same thing. So if you're confused, I just took the fourth root of 16 and cubed it. These are the same thing. All right, so then here, this is basically -1 times 25. So the square root of 25 is 5 cubed negative, and then that's -1 times that. So we could do it like that, -125. And if you look back here at your answers, you can see, oh, they're on there. This here, we know that the cube root of 1 is going to equal 1. So the cube root of 0.001 is going to be 0.1. All right, because if you 0.1 times 0.1 is 0.01, and then that times 0.1 is 0.001. Okay, here we've got the fourth root of 81, -81. Now keep in mind that the negative number is fine. Write that down. Negative number is just a negative number. I know that sounds weird, but a negative exponent is the reciprocal. So please make sure, before we learned about negative reciprocals, that was never even a problem. But now you need to know the difference between the negative number and the negative reciprocal. The negative number is not a problem. All right, hold on one second. Let me. Brianna Lavelle. Mm-hmm. Mm-hmm. Hold on one second. Okay, y'all, sorry about that. I guess I need to be able to pause it faster. Okay, so here we've got the fourth root of 81 negative. So we need to know what number multiplies by itself 4 times. Now, if you need to work that out, you just need to say, okay, 81 breaks down into 9 and 9, 3 times 3, 3 times 3, and I need 4 of the same number. I've got 4 3s. So that's going to come out as -3. Okay. Now, if this negative was not there, it would just be positive. Oh, I'm paused. I don't know why it's not showing. There we go. Sorry about that. So we've got the 81 broken down like this. If I could edit this, I would, but I don't know how to do that. Sorry, guys. Okay, so then we've got the 6th root of negative 64. This is going to be, 8 times 8, and then we know 8 is the cube root of, so look at that, we've got 6 2's. Now, keep in mind that a negative number, you cannot have a even root of a negative number. So even though there are 6 2's here, and the temptation is to write 2 or negative 2, the answer is actually no solution, because it is no real numbers. No real solution, I guess, should be the. All right. And I think that that might be on your answer key. No real root at the bottom. So now we've got moving on to here. Now this we know we can rewrite as the square root of 16 over the square root of 36. So if we take the square root of both of those numbers, we're going to get 4 over 6, which is 2 over 3. Another way to do that is you could reduce this first. You could 16 and 36 can be broken down. 4 goes into 16 4 times. 4 goes into 36 9 times. So the square root of 4 over 9, and that would be 2 over 3. So you can do it either way. You can reduce this fraction first and then take the square root, or you can take the square root first and then reduce. Now, if it's perfect squares, it won't matter which way you do it. If it's not perfect squares, then you need to do the way that it's going to simplify the best. All right, now here we've got a negative 2 over 5. So I need the 5th root of this. Well, I don't know what the 5th root is, so I'm going to have to work that out. 243, that's 81. Oops, 81 and 3. Well, now I know that this is 3, 3, 3, 3. So that's going to be 3 squared, right? Because the 5th root, remember, we can write that as 243 squared, the 5th root, or 243 squared with the 5th root. So that's going to be 3 squared, which is 9. Okay. Now we've got the 4th root of 16 and 81 over 16. And again, I can reduce this first if there's a number that evenly divides into 81 and 16. I don't know of a number that does that. The 4th root of 81 is 3. The 4th root of 16 is 2. And again, we've got negative 1. Oh, shoot. This should have been 1 over 9. Sorry, you guys. I hope you were screaming at the computer. This should be 1 over 9. And the reason is because we have a negative exponent. So since our answer is 9, it's 1 over 9. Hopefully you're noticing that I made that error. And again, negative 27. So we've got the third, the 3rd root of 27 squared. The 3rd root of 27. Oh, and that's to the negative 2. The 3rd root of 27 is 3 to the negative 2. 3 to the negative 2 again is 1 over 9. Okay, so similar to that one. This should be to the negative 2 power, which would be 1 over 9. And then here we've got 0.000027. We know that this number here is going to be 3. And then you just have to, since it's the cube root, we have to 1, 2, 1, 2. So we're going to, and it would be a negative. You can have a negative out of a cube root. Okay. All right. Hopefully that helps. Moving on, simplify the following. All answers should be in exponential form. So that's where we have x to the 1 over y type of thing, whatever that might be. And no negative exponents. So if we look at this, you can rewrite this as 3x plus 6 to the 1/5 power over 3x plus 6 to the 4/5 power. So this I can say is going to be 3x plus 6 raised to the 1/5 minus 4/5 power. So then you're going to get 3x plus 6 to the negative 3/5 power. And when you rewrite that, I'm going to have to go over here. Well, just right here. It's going to be 1 over 3x plus 6 to the 3/5 power. Okay, let's look and make sure that we have that. There you go. This one here. Now, here's where it kind of gets a little bit fun as far as figuring these things out. You've got 4x to the 1/2, y to the negative 1/3. And let me just say this. There are lots of ways to do this. There is not one perfect way to do these because you're multiplying and dividing, and you can multiply and divide. You can divide, you can multiply. It doesn't matter the order. You should still get the same answer. This all squared. So I'm going to go ahead and distribute that 2 to everything. So I'm going to get 4 squared. 1/2 times 2 is x, or is 1. So that you can just put 1. Y to the negative 2/3 over 5 squared, x to the 2/3, y to the 5 over 3, z squared. 5, 6 times 2 is going to give you 5/3. Now at this point, I've got x's and y's all up and down, so I can't have that. So I need to have no, just either x's on the top or x on the bottom. So this is going to be 16. This will be x1 minus 2/3. We can do it this way. Y negative 2/3 minus 5/3. And then z minus 2, if we want to do that. That's all in the numerator. I've just moved everything up except for the 25. You don't have to do it this way. You can do it however way you want. So this is going to be 16x to the 1/3. 1 minus 2/3 is 1/3. Y to the negative 7/3. Z to the negative 2, all over 25. And now I need to move my negative exponents below. 16x to the 1/3 divided by 25, y to the 7/3, z squared. Those are negative, they go below. So then I'm just going to check and make sure. And there it is. Okay. The next one is 5xy squared to the 1/4. 5xy squared to the 7/4. Now, let me tell you this. Again, there are multiple ways to do this, but I see this. These are the same base. Same base. So what I can do is if I were to have x to the 1/4 times x to the 7/4, I could add those together and I would get x to the 8/4, which would be x squared. Well, I can do the same thing here because I've got the same base. So I can just change this to that. Because when I add these two together, now the only reason I can do that is because I have the same base. If you don't see that, that's okay. You're going to have to distribute and then it'll all still work out to be the same. But So now I distribute that squared, 5 squared, x squared, y to the 4th, and that's going to give me 25 x squared, y to the 4th. And that should be on my page. All right, next, that's 13. 14 is going to be the x squared 4th root of x to the 14th. Now again, I've got both to the 4th root, so I can combine these both under the same radical, x squared times x to the 14th, which would be the 4th root of x to the 16th. And now if I create that into a fraction, I can simplify it like that. And there you go. Moving on, just check your answer sheet, make sure you've got it. All right. Number 615 is the 5th root of a to the squared times the 5th root of a. This would be just the 5th root of a cubed, which is a to the 3/5. All right, number 16, x to the negative 2/5 times x to the 1/2 plus x to the 2/3. Now, here's where you really just have to keep in mind, when you're multiplying, you add, right? So now we need to add some fractions. So this is going to be x to the negative 2/5 times x to the 1/2 plus x to the 2/3 times x to the negative 2/5. So since I'm adding these, I need to actually get the same denominator. So negative 2/5 plus 1/2. I'm going to change this to negative 4/10 plus 5/10, and I'm going to get 1/10. So this is going to be x to the 1/10. And then we do the same thing here. 2/3 minus 2/5. I'm going to get 15. So that's going to be 10/15 minus 3 times both of here is going to be 6. So I'm going to get plus x to the 4/15. Okay, so that's how you work those. Moving on. The next one is number 17. And again, these can get a little convoluted and you can work it in multiple ways. So I've got some parentheses, brackets, parentheses, and you know, brackets are just the same as parentheses, just a different, just letting you know that it is one step removed. So here on this one, I'd kind of like to maybe, I can multiply these two. So then this can become 3x squared y to the negative 4 to the 4th power, because 2 times 2 is 4. And I know that if I have x to the 3rd to the 4th, I multiply those. Well, that's no different there. So I'm going to multiply those. I'm going to get this, and then I'm going to multiply again. So I get 3 to the 4th, x to the 8th, y to the negative 16. And then that again, 3 to the 4th, we know is 81, x to the 8th, and then this negative exponent causes this to go into the denominator. All right, moving on. Y'all are doing so good. That's awfully blurry. Okay, number 18 is going to be negative. Now that's a negative number, so we're not worrying about flipping the reciprocal because of that negative, but we are worried about flipping it because of this negative. Now, there's 2 ways you can do this, or multiple ways actually. I can go ahead and flip it and take that negative away. So I could just go ahead and say y squared 5x cubed to the positive 2 and work it that way. I can go ahead and distribute that negative, because if I have negative exponents in here, then it's going to change it to positive. So there's lots of rules of thought on that. Since I don't have any negative exponents, I'll just go with it here, but you could just multiply that by negative, 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 and eventually change it. But this is going to be a negative y to the 4th, and then this is going to be 25x to the 6th. And there you have that. I think that that's one of the answers. Let's double check. Yes. There you go. Then our next one is number 19, a to the 4th, and then this is the 3rd index. So keep in mind the difference between an exponent and the index. A squared y to the 3rd. Now I can write this as a to the 4th. I can rewrite this as 2/3 and y 3/3. So this becomes, now I need to add these. So I need to add 4 plus 2/3. I have to change this 4 to 12/3, 2/3, which I get 14/3. So this becomes a to the 14/3, y to the 1. All right. And let's see, I've got that right there. Moving on, number 20, we've got the square root. Now we're doing radical form. So you need to know both. You need to know both the exponential form and the radical form. I don't know what's going on here. There we go. So we've got 50, the square root of 50x to the 4th. Now remember, this is a 2, so I'm going to multiply 25 and 2. The square root of 25 is 5. The 2 stays in. 4 divided by 2 is 2 with no remainder. So there's 20. Then we've got, I love how high tech I am with all of this stuff. Sorry, you guys. Then I've got this, the cube root of 48, x cubed, y to the 4th. We know that 48 is 16 times 3, which helps us if we are taking the square root, but it doesn't necessarily help us if we're taking the cube root until we say, okay, that's going to be, 2 times 8. And then all of a sudden we know that 8 is the cube root of 2. So we're happy about that. These two numbers stay inside. I can take this out, but these stay inside. So I'm taking the 2 out and I'm leaving 2 times 3 in, which is 6. I've got 3 x's, so I can take one of those out, none stay in. I've got 4 y's, so I can take 1 out and 1 stays in. 4 divided by 3 is 1 with 1 left over. And there is your answer for that. And that's this weird one that I told y'all to change. All right, moving on. 22 is the 4th root of 81, x to the 12th, y to the 15th. Yeah, anyway, there's, so the 4th root of 81 is going to be 3. So I can take 3 out. 12 divided by 4 is an even 3. And y divided by 4 is going to be 3, but I have 3 y's left over. No, yes. 3 y's left over. Lots of 3's in that answer. And there it is. Moving on, number 23, right? Number 23, negative 5x cube root of 27x cubed. Now, I know I can't have a radical in the denominator, but luckily, this is a perfect cube and this is a perfect cube. So when I just simplify that, I'm going to get 3x and I don't have to worry about it. Then I get negative 5 over x, but I can still simplify that to negative 5 over 3 because the x's will then cancel out. All right. Number 24. The fourth root, sorry, of 32. A to the fourth, b to the fifth. This can be broken down to 2 and 16, which is 2 and 8, 2 and 4, 2 and 2. So I've got 1, 2, 3, 4, 5, which keep in mind that means 32 is 2 to the 5th power. So I'm getting tired of that color. I'm gonna change colors. I need 4. So I take the 2 out and I leave this 2 in. Get the 4 A's. I've got 4 A's, so A is going to come right out. B, I've got 5 B's, so 1 comes out and 1 stays in. All right. All right, moving on. 25. Cube root of 24. Oh, good. 8 to the 8th, B to the 14th. What multiplies to give us 24? 3 and 8. And the reason why I picked that is because I know 8 is a perfect cube. Won't matter if you pick 4 and 6, 2 and 12, eventually you'll get to 3 times 2 times 2 times 2. So I can take the 2 out and I'm leaving the 3 in. And notice how when I write this, I like to leave some space. This is my index of 3. 8 divided by 3 is 2 and 2/3. So this is going to be 8, or I'm sorry, a squared, because that's how many I can pull out. And I'm left with 2. And then 14 divided by 3 is going to be 4, right? 3 goes into 14 4 times, and you're left with 2. So this is going to be B to the 4th, right? This and this. And I'm left with 2 B's left. So there is that. And we've got that right here. Perfect. Cruising along to page 2 of the thing. And I think I'm going to end it right there and then start another video. So that way it won't be quite so long.